Hey students, this is a video on section 13.3, which is arc length in space. Even though that's the title of the section, the first thing we're going to be learning about is called the unit tangent vector. So what we've learned so far is that r of t is the position of a particle at time t. Okay, that's for a vector function. And then remember that v is the same as a tangent vector. It's dr dt. So v equals dr dt. And we call that the velocity at time t. Velocity at time t. And remember, when you're taking the derivative, that's the same as the slope of the tangent line. So v is actually not just the velocity, but it's also a tangent vector to the curve. As you can see here, this is a sketch of v. This is our r of t in black, and then in red we have v. And it's got to be tangent to the curve. Okay, so velocity at time t is tangent to the curve. So what we call it is a tangent vector. Okay? Since it's still a vector, we call it a tangent vector. So v is a tangent vector. Okay? V is a tangent vector. And then when you're doing physics or whatever it is you're working on, people don't usually just want a tangent vector. They actually want what's called the unit tangent vector. Okay? So the unit tangent vector, written as t, is what they'll usually ask you for because it's more useful in most problems. So t equals v divided by the length of v is the unit tangent vector. Okay? The unit tangent vector. Alright, and I'm going to box that because that's the first thing that we do in this section, is find the unit tangent vector. Okay, but it should make a lot of sense why it's called the unit tangent vector, since we know that v, the velocity, is a tangent vector. When you divide the velocity by its length, that gives you a unit vector. Right? Remember, if you divide any vector by its length, that's a unit vector. And then since it's the velocity divided by its length, it's actually a unit tangent vector. Okay, so that's the first thing we're going to be learning about how to find in this section. And then later on we'll be finding arc length. Okay? Alright, so let's see an example of this. Okay, so example. We're just going to have one example for this section, but it's going to be very long. I chose the hardest problem I could find. Okay, so for this one, the instructions are find the curve's unit tangent vector, find the curve's unit tangent vector, okay, so that's the capital T that we wrote up here. Also, find the length of the indicated portion of the curve. Okay, so also find the length of the indicated portion of the curve. And that second thing that they're asking us to do that's actually going to be finding the arc length, which is actually even easier than finding the tangent vector, the unit tangent vector. Okay, but the information they give us for this problem is our position vector r of t equals 4t cosine of t times I plus 4t sine of t times j, okay, plus 8 root 2 over 3 times t to the 3 halves times k. Okay, so 4t cosine of t times I plus 4t sine of t times j plus 8 root 2 over 3 t to the 3 halves times k. And here they say t is from 0 to pi. Okay, so t is greater than or equal to 0 and less than or equal to pi. Okay, so what we're going to do first is we're going to find the curve's unit tangent vector. Okay, and remember that that's this t that I wrote up here. So the unit tangent vector is v divided by the length of v. Now it can take a while to find it because first you have to find v, then you have to find the length of v, then you have to divide. Okay, so that's why I'm only doing one example because it's so long. Okay? So let's start with v. So v of t, remember, is the derivative of r. So v of t is equal to dr dt. dr dt. Okay, so to find v of t, you just take the derivative of each component. Now, these are going to take a long time to take the derivative of, so let me give myself some room here. I'm going to zoom out a little bit. Okay. So we know that v of t equals dr dt. Oops, did not mean to do that. Okay, so v of t equals dr dt. dr dt. Okay, and so we need to take the derivative of each component here. So let's start with the 4t cosine of t. Now here, if you have something multiplied together, you're supposed to use the product rule. So I don't know if you remember the product rule, but it's going to be, you need to label the different parts. So here our u is going to be 4t, and then our v is going to be cosine of t. And then when we take the derivative, for the product rule, the rule is uv prime plus u prime v. So this is going to give us uv prime plus u prime v. Okay? And that'll be times I. And then we're going to have to do the same thing for j here. So once again, we're going to be using the product rule, uv prime plus u prime v. Here our u is going to be 4t, and then our v is going to be sine of t. So once again, we're going to have, using the product rule, we're going to have uv prime plus u prime v times j. Okay, and then for the last term, we don't have to use a product rule because 8 root 2 over 3 is just a constant. So we're just going to be using the power rule here. So we're going to take the derivative of t to the 3 halves, which means we basically just factor out the exponent and decrease it by 1. Okay, so if I bring out the 3 halves and decrease it by 1, I'm going to end up with 8 root 2 over 3 times 3 halves t to the, well, what's 3/2 minus 1? That's actually 1/2. So now we're going to have t to the 1/2 times k. Okay? And then we still have to simplify this stuff. So uv prime for the red part, well, the derivative of cosine is negative sine. So for there, we're going to have 4t times negative sine of t. So we're going to have negative 4t sine of t. That's our uv prime. And then for our u prime v, the derivative of 4t is just 4. So we're going to have plus 4 cosine of t. Plus 4 cosine of t. Okay, and that's times I. Okay, and then we do the same thing for blue in the middle. So here, u is 4t, v is sine of t, and the derivative of sine of t is cosine of t. So uv prime is going to be 4t cosine of t. Okay, so we have 4t cosine of t. And then we have plus u prime v. That's going to be plus 4 times sine of t. Plus 4 times sine of t. And then that's all times j. Okay, and then for the green part on the right, we can cancel out the 3's. And then 8 divided by 2 is 4. So we're going to be left with 4 root 2 for our constant. So we have 4 root 2 times t to the 1/2. 4 root 2 times t to the 1/2. And that's times k. Okay, so what we just found here, this big long thing, is actually our v of t. Now that's not the unit tangent vector though. It's a tangent vector, but they asked for the unit tangent vector. So to get a unit tangent vector, we're going to have to divide this by its length. Okay? So the next thing we need to find is the length of v. Okay? Because we're going to need that later on. We're going to divide this by its length. Okay, so for the length of v, we're going to have the square root of the sum of the squares. Okay, the square root of the sum of the squares. So what we're going to have is square root of negative 4t sine of t plus 4 cosine of t, quantity squared, and so forth. So we're going to have plus 4t cosine of t plus 4 sine of t, quantity squared. And then for our last term here, we're actually going to have plus 4 root 2 t to the 1/2 squared. Okay, so plus 4 root 2 t to the 1/2 quantity squared. So really a lot going on there for the length. But we can do this. It's just a lot of squaring. So here, one thing we can do to simplify these is just use FOIL, probably the easiest way. And we could also factor out a 4 at the beginning just to make our lives a little bit easier. So if I factor out a 4 here, then we're going to have 4 squared times negative t sine of t plus cosine of t squared. And then also factoring out a 4 from the second one, we're going to have 4 squared times t cosine of t plus sine of t squared. And then for the last one, 4 squared is 16, and root 2 squared is 2. So we have 16 times 2, which is 32. So we have 32, and then t to the 1/2 squared is actually just going to give us t. because you multiply the exponents. Okay? And I know it looks complicated, but you're going to find that a lot of this stuff is going to simplify. So first of all, the 4 squared is just 16. Okay, so this is 16, and this one over here is 16. All right, and then we can go ahead and use FOIL for this one. For the first term and for the second term, we can use FOIL. Okay, so that's going to give us, we can factor out a 16 from these first two terms. So if we factor out a 16 and give ourselves lots of room, actually maybe even more room than that, we're going to have a 16 out front, and then we're going to have, using FOIL for the first set of terms, we're going to have t squared sine squared of t for the first, t squared sine squared of t, and then we're going to have minus t sine of t cosine of t minus t sine of t cosine of t. So that's going to be minus 2t sine of t cosine of t. That's the outer plus the inner. And then for the last here, we're going to have cosine of t times cosine of t. So that's going to be cosine squared of t. Okay, and that's just this first one here. So that right here was this one. Okay, and so that's right here. And then now we need to do the second FOIL, this one over here. Okay, so that's going to be, once again, we have a 16 out front. So we're going to have 16 times, using FOIL, we have t squared cosine squared of t. Sorry, my writing's going downhill. I'm not used to writing so small. So t squared cosine squared of t, plus the outer is t sine of t cosine of t, plus the inner is t sine of t cosine of t. So that's going to be plus 2t sine of t cosine of t. Okay, and then we have plus the last. So here the last is going to be plus sine squared of t. Okay, so plus sine squared of t. And as you can see, we just did the green part, but I still need more room to write stuff. And since I probably can't really zoom out more, I'll just go down to the next line a little bit. Wait, can I zoom out? Oh, maybe I can zoom out more. All right, there we go. So making it even bigger, at the end here we have plus 32t. All right, I know it's a little bit hard to read though, so let me get a little bit closer. All right, so it turns out you can actually simplify all of this. Even though it's very messy, what we can do is we can factor out a 16 from this whole thing, from the first two terms. So if I go ahead and factor out a 16 from the first two terms, and then I can put parentheses around all this. Then we're actually going to have this now. Alright, and then what we can do is we can combine like terms. Oh no, I erased it. That's not good. Gotta be careful with that eraser. Okay, so what we can do now is we can combine like terms. Alright, so the like terms here are, we have the t squared sine of t and the t squared cosine of t. So for those, we can write it as t squared times sine squared of t plus cosine squared of t. Okay? And then the other like terms we have are negative 2t sine of t cosine of t and positive 2t sine of t cosine of t. So for those, because they're opposite signs, 2 minus 2 is 0. So those just cancel out. Okay, so we don't have to worry about those anymore. And then the last like terms that we have here are cosine squared of t and sine squared of t. Okay, so we have a plus sine squared of t plus cosine squared of t. Okay? And we still have a 16 factored out front here. So I'll put brackets around it. And then we also have a plus 32t over here. Okay? Now remember that from trig, that sine squared of t plus cosine squared of t is just 1. Okay, so this one right here is 1. And then the green one is also 1. So actually all we really have here is t squared times 1, which is t squared, plus 1. So all that simplified. So now after all that work, we actually just end up with 16 times t squared plus 1 plus 32t. Okay, and of course you just keep going with these until you're done simplifying. So the next thing we would do would be we would distribute the 16. Okay, so if we distribute that 16, then we're going to get 16t squared is our highest power. Our next highest power is 32t. And then our lowest power is going to be plus 16. And like I said, you just keep going with these. So what's next is we can actually factor this. And I probably shouldn't have factored out the 16. I'm sorry, I probably shouldn't have distributed the 16 because we're going to end up needing to factor out a 16 again. But as you can see here, the greatest common factor here is 16. So if I go ahead and factor out a 16 from the entire expression, we're going to have 16 times t squared plus 2t plus 1. Okay? And for t squared plus 2t plus 1, we can actually factor that. So using the x method, if you can't do it in your head, you write the third term on the top, and then you write the second term on the bottom. Okay, and then you want two numbers that multiply to the number on the top and add to the number on the bottom. So 1 times 1 is 1, and 1 plus 1 is 2. So that means that this factors as t plus 1 times t plus 1. But t plus 1 times t plus 1 is the same as t plus 1 quantity squared. Okay, so we actually have the square root of 16 times t plus 1 quantity squared. And then we can finally apply the square root. Okay, so the square root of 16 is 4. And the square root of anything squared is just whatever it is on the inside. So the square root and the square are going to cancel. So we're going to have 4 times the quantity t plus 1. And there might have been some other way of doing this that had fewer steps. But at least I did it this way. I don't really know of an easier way of finding the length of v. But there might be some way. But anyway, after all that work, we actually got something that's pretty simple. And that thing that we just found there, that was the length of v. Okay, so our length of v is 4 times t plus 1. Alright, so like I said, these problems are long. So we have the length of v, And then we also have v of t. So what they asked us to find, was the curve's unit tangent vector. Okay, so that's capital T. Capital T equals v divided by the length of v. Since we now have v and we also have the length of v, we can just plug those in here to find the unit tangent vector. Okay, so the unit tangent vector, well, that's actually just written as capital T, which is v divided by the length of v. And we already calculated v. So way up here, we calculated that v was, the first component is negative 4t sine of t plus 4 cosine of t. Negative 4t sine of t plus 4 cosine of t. And that's all times I. Okay, and then our next component was 4t cosine of t plus 4 sine of t times j. Okay, so 4t cosine of t plus 4 sine of t times j. Okay, and then our last component of v was 4 root 2 times t to the 1/2 times k. And remember, t to the 1/2 is actually the same as the square root of t. So I'm going to write it as 4 times root 2t times k. So we're going to have plus 4 times root 2t times k. Okay, and that's v. That is v right there. And then we're supposed to divide by the length of v. Okay, so we're supposed to divide by the length of v. And the length of v we just calculated is 4 times t plus 1. Okay? So we're going to divide every single term by 4 times t plus 1. Okay? And then if we plug that all in, notice that every term on the top actually has a 4 already. So right off the bat, we can just cross out the 4s everywhere. So every term has a 4 on the top, and then we also have a 4 on the bottom to cancel out with. So really all we're going to have to do is write each term over t plus 1. Okay, so for our tangent, for our unit tangent vector t, we're going to distribute that t plus 1 to each denominator. Okay, so we're going to have negative t sine of t plus cosine of t. Negative t sine of t plus cosine of t divided by t plus 1. And that's our I component. And then for our j component, we have t cosine of t plus sine of t divided by t plus 1. That's times j. Okay, and then for our last component, we just have root 2t in the numerator. So we have root 2t over t plus 1 times k. Okay? And so then that's about as simplified as it gets. So you can't really simplify it any more than that, so that's going to be our answer. Probably the only thing they would do is this subtraction here, they might switch the order, but it's not a big deal. Like here, instead of writing negative t sine of t plus cosine of t. They might switch the order and write it as cosine of t minus t sine of t. But other than that, we're identical to their answer. Okay, so we're good there. Okay, so that right there is the unit tangent vector. Now the other thing they asked for us to find was actually the length of the indicated portion of the curve. Okay? So before we do that, I want to talk about arc length in space. Okay, so I'm going to box this one. This was our answer. That's our unit tangent vector. Now let's talk about arc length in space before we do the next part. Arc length in space. So it turns out that, I don't know if you remember what arc length means, but it turns out that arc length is actually sort of like the distance formula, but you're tracing out the distance along a curve that's turning around. So if you want to find the arc length in space, you're actually finding the total distance traveled by a particle from one point to another point. So if you can imagine your curve r, which is your position, and this is some curve in space moving along. I always like to do a curly Q, but it can be any shape. If you want to find the arc length, that's the same as the distance traveled from one time to another time. So for example here, this might be where t equals 0, and then at the end over here, this might be t equals pi. And the arc length would actually be the same as, well, what is this blue distance that we travel if we go all the way around here, following the curve until we get all the way up to here. Try making it a little bit darker so you can see it. Well, the distance traveled, as we trace along that curve is the arc length. That's what arc length means. How far did we travel in space? Okay, and it turns out that the way you do that is you actually just integrate the length of the velocity vector. Okay, so the formula for arc length, oh my gosh, I can't write anymore. The formula for arc length is arc length equals the integral from, well, here it's from 0 to pi, but in general it's from a to b. It's an integral from a to b of the length of your velocity vector v dt. Okay? And the reason it works is, remember, your velocity vector is the same as a tangent vector. Okay? It's not the unit tangent vector, but it is a tangent vector. And it turns out that if you integrate the length of a tangent vector, that ends up measuring the entire distance as you integrate it, as that tangent vector moves along the curve, because it traces out the shape of the curve, and then as you're integrating it, you're finding the distance that you traveled. Okay? So it's pretty cool, and it's actually a pretty easy formula. Okay, so let's use this formula to go back to our problem. So for our problem, they wanted us to find the arc length from 0 to pi. Okay? So returning to our problem, we needed to find the arc length from 0 to pi. So it's going to be the integral from 0 to pi of the length of v of t dt. But remember, we calculated the length of v up here. So way up here we said that the length of v was 4 times t plus 1. Okay, so we're going to be using that formula down here. Okay, so it's the integral of 4 times t plus 1 dt, which is actually a really easy integral. I can't promise that all the ones on your homework will be this easy, but this one's nice. Especially considering how much work we had to do earlier. It's nice to have an easy part. So anyway, here to integrate this, we can just factor out the 4 and then integrate each term. So we've got 4 times the integral from 0 to pi of t plus 1 dt. Okay, and integrating t, using the power rule, we add 1 to the exponent and we divide by the new exponent. So that's going to give us t squared over 2. And then for the second term, the integral of a constant is the constant times the variable. So the integral of 1 is going to give us t. And then we still have a 4 out front. So we have 4 times t squared over 2 plus t evaluated from 0 to pi. Okay? And then all we have to do is use the fundamental theorem of calculus part 2. So we're going to plug in the top number into this function and then subtract the entire function valued at the bottom number. Okay, so what we're going to have here is we got the 4 out front, and then plugging in pi, we have pi squared over 2 plus pi, and then we subtract the entire function evaluated at 0. So that's going to be minus 0 squared over 2 plus 0. Okay? And remember that 0 is 0, so all this over here is just going to be 0. So all we're really left with is 4 times the quantity pi squared over 2 plus pi. And we can just go ahead and distribute that 4. Okay? And I think that's all they make you do. Yeah, they just distribute the 4. So we're going to have 4 divided by 2 is 2 pi squared plus 4 pi. 2 pi squared plus 4 pi. Okay, and what that is that's the arc length, which is the same as the length of the indicated portion of the curve. So as your particle moves along your curve, whatever the curve shape is, from time equals 0 to time equals pi, imagine that the distance traveled by that particle, that's what we just found there as it moves along the curve. Okay? In other words, the length of the indicated portion of the curve is 2 pi squared plus 4 pi. Okay? So that's the length of the curve from t equals 0 to t equals pi. And these are very useful in physics because in the real world, many things are measured as vectors. Because you think about the real world, we're talking about space. We have 3 dimensions. So it makes sense to describe things like position, velocity, acceleration, and other things as well with vectors.